Getting good. Hi, this is John Bennett, Dr. John Bennett from Miami, Florida, having our pre-conference hangouts for the Watch conference in Indianapolis at the end of this month. The topic for the Watch conference is wearables, the future of wearables 2014. And today we have the honor of having Ned Sahin, PhD, a neuroscientist, graduate of Harvard, who's the owner, I guess, and CEO of Brainpower, a company based in Boston that is currently utilizing Google Glass and studying autism, which is a field, as everyone knows, that needs a lot of research and needs a lot of study. And Nate was nice enough to take time out of his, Ned was nice enough to take time out of his vacation in Turkey. Thank you very much, Ned, and greetings.
Greetings, thank you. Real honor to be here.
Okay, let me just, and also we're being joined by John Hewitt, who's a neuroscientist also. He's an online writer of lots of articles.
How you doing?
Okay, Ned, could you briefly describe your background before at Harvard? Well, I tell you, one thing I like to ask people like you who are pretty internet smart is, how'd you first start with the internet? What was your first computer, and how'd you come upon it, and etc.? Can you start from there, please?
Sure, if you want. Well, so we had TRS-80, VIC-20, Commodore 64. We had kind of the early machines, and my dad had a Super Brain, which was essentially a portable machine. It weighed about as much as I did at that time, and it was integrated. It had one small green screen in it, and two 5 1/4-inch disk drives, floppy, and you put one the system and one whatever you were trying to run. So that was kind of back in the day, definitely pre-internet. And I probably surprised my, I think, second grade teacher by bringing in essentially a word processed document that was on WordStar, so it was not WYSIWYG. You had to embed little commands to format. In any case, so I kind of got an early start. And in terms of internet, I remember I built a computer in, I think it was grade school, not high school yet, because the one I had wasn't powerful enough to run this new windowing operating system, Windows. So I built one and kind of built a little windowing operating system myself, but very, very rudimentary. But I had no internet connection. I started realizing that was important, and so I finally was able to connect and access BBSs. Of course, that's what there were. No web at that time. Bulletin board systems. It was quite cool. CompuServe being a big one. I was able to download things, upload things, communicate with other people of unknown age or location out there. It was very cool, but it was all text-based. So those were my early forays into
That's
computers.
a while ago.
Yeah, it was a while ago.
And you continued on with, did you have a tremendous amount of enthusiasm for it initially, or did you get into neuroscience, or you kind of use them together, or?
Well, neuroscience, so I remember, I don't know exactly where my, first of all, scientific predilections came from, but there is a, what do they call it, when they do a drawing that's a caricature drawing of me when I was quite young, but I was holding two test tubes. So somehow I had told this caricature artist when I was 4 that I wanted to be a scientist. And so I had kind of early inclinations in that direction, but I also kind of disassembled electronics around the house, and electronics meaning like a basic calculator or a remote control, and wanted to redesign things. I thought the vacuum cleaner was very noisy and inefficient, and I created a little manual prototype of a new vacuum cleaner when I was a kid. So I kind of had an engineering sense to myself, but basically I wanted to be a scientist. And then my father got me excited about neuroscience. It's like as mysterious as the depths of space, but located inside your head, and the brain controlling everything we do, love, think, speak, and so forth. seemed pretty good topic of study.
Mm-hmm.
Kind of had that early on. Early high school, did some independent study. I had kind of finished the science track for my high school, so I was able to do an independent study and studied the neuroscience of dreams with some researchers at Harvard, Bob Stickgold and Alan Hobson, and continued on from there. Really was into neuroscience as a major, but there was no major per se in high school in that. And then in college there was, or at least a concentration. Continued on, did research in the summers in labs at hospitals in the Boston area, part of the general Harvard hospital system, and continued. So I'll wait for your next question before I just diatribe on here for too long.
No, it's good to hear that. I just I'm always curious about backgrounds of people as it relates to computers and stuff and how they get into it. It seems that most of the docs I run into, they took to it very quickly as soon as computers came around. And things, as you know, are different today with kids because they're surrounded by computers.
Oh yeah.
When I grew up, the computers weren't around. There was a language called Fortran. I don't know if you've ever heard of that language, but that's ancient.
Fortran, COBOL, whatever. Sure.
That's old. But okay, so then you went to Harvard. Did you major in neuroscience in Harvard, or you took a general curriculum, or how'd that work?
Well, just clarify. So undergrad was at Williams College,
Okay.
and I spent some time at Oxford as well. Still, I was in neuroscience, as I said, biology and neuroscience.
Okay.
And at Oxford, it was a little bit more of I was focused on language in the brain. So there I studied the history of English language and psychology of language and some linguistics. Anyway, back to the U.S., and then I did a master's degree at MIT and then the PhD at Harvard. So by the time I got to Harvard, I was very specific. I was very focused on neuroscience. But undergrad was it's a liberal arts college, but I focused on biology and neuroscience at Williams. But at Harvard, by that point, I was very focused and studying the language system. My advisor was Steve Pinker, and he's done a lot in language generally and the cognitive side and psychology side of language. And I was bringing to it neuroimaging research, trying to understand the details of the brain-based systems for language, and then as well the brain's own language, how parts of the brain speak with each other during a cognitive task. And fMRI, my tool at that point, only went so far. There's a temporal resolution issue and as well as spatial limitation. So we had really great luck. I allied with another lab group of Dr. Eric Hallgren and got access to patients who have electrodes implanted directly inside their brains. So that's to say they have a craniotomy, a type of surgery, and electrodes are implanted both on the surface of the brain and penetrating deep into the brain, into the language centers, for instance. And this is to find the source of epilepsy. Epilepsy being, I don't want to state it in a cartoon sense, but something like an electrical storm. And if you can find the offending part of the brain and disable it, you can quell the seizures. So they need to choose that extremely carefully and guide it based on the seizures from that patient, as well as mapping the cognitive abilities that the patient had spared, so you don't delete memories of childhood or your years of piano lessons. So the electrodes go in for stage 1 of the surgery. Stage 2, they use the data that they found and eliminate or disable that part that's causing the seizures. Along the way, they very finely map the cognitive abilities of the brain. And we were able to use data during those procedures to understand cognitive systems of interest, in this case language. So we were literally listening to the brain cells or groups of cells talking amongst each other while the patient was talking to me during the experiment. And that gave us the ability to look closer. And we looked closely within Broca's area, a storied part of the brain that is related to language, and found some cool things. One, for instance, we found 3 different computations within language, totally orthogonal to each other. the sound form, the structure, and the meaning of the word as best we could tell from our paradigm. So there are three functions of language separated not in space but in time. So what does that mean? One way of looking at the brain is just a collection of individual computational units that have their specialty. And what you can do is parse the brain down and find a zip code for a function, which at the end looks a lot like phrenology, but in Technicolor and with modern methods. But what we were seeing in this case was that it wasn't a compartmentalization by space, but rather by time. So that in overlapping, or at least partially overlapping, partially non-overlapping centers, there was a progression through time of this function. Anyway, so that was good enough to get a paper in Science, so I was pretty happy about that, and so forth. So that was the level of the detail of the research during my PhD. I'll continue forward, but I'll wait for your question.
Oh, okay. Well, John, do you have any questions you'd like to ask Ned?
Yeah, since you mentioned Broca's area, I mean, the traditional ideas of that being an output area, motor area, versus Wernicke's an association sensory area, do those ideas still hold up? I mean, are views shifting that, you know, the axons coming out of and into both areas are two-way with the thalamus and lower areas?
They hold up my computer monitor because they're in the textbooks that are underneath it. Now, in every book right now, but they're wrong. They're completely wrong, and we've actually known they're wrong for a long time. They being the ideas that it's Wernicke's in and Broca's out, or Wernicke's for understanding comprehension, and Broca's for expression and speaking. No, absolutely not the case. Our data, of course, obliterate that kind of view because you're talking about three functions that overlap both of those cartoon versions of what the two do, located deep within Broca's area only. So the ideas hold up to rigorous current scientific scrutiny, but they're still printed and reprinted and mimeographed in current textbooks.
So if you have expansive subdural electrode arrays covering all these areas, and you're looking for seizures, how do you know if it's a cortical origin or a hippocampus origin if you can't listen to the hippocampus?
So first of all, there are surface subdural electrodes. At the surface, they have laminar probes that at 20 micron spacing can go through the cortical lamina and listen to layer-by-layer communication, sometimes single unit, sometimes multi-unit. Then there are also penetrating depth electrodes, Benke-Fried types, where you have maybe half a centimeter spacing contacts, and they go in, penetrating to or toward the hippocampus, amygdala, various other parts of orbital frontal cortex, and so forth. So they actually do have localization type data where you can triangulate in 3 space.
Yeah, you mentioned amygdala. It's a big word, this laser amygdalo-hippocampectomy I saw recently, where they use a robot to guide a probe in from the back, and they try to navigate along the axis of the hippocampus and target both the hippocampus and amygdala for a laser ablation. That seems like a fascinating, complex procedure. Wondering if you've heard much about that.
I haven't, and I luckily got to shave some years off my training. I'm not a clinician. I'm a PhD, not an MD, but some of my best friends are. I hang out with neurologists and neurosurgeons. It's quite nice, and neuroscience has been a leader in this sense where I get to be in the OR, for instance. I get to see the brain pulsing under open craniotomy, and I get to see where they've placed the electrodes for the research. So I get that access, but I'm not the clinician, and I'm not guiding the surgery nor the placement of the probes. And so I'm not current with new types of surgery. It does sound very interesting.
Well, you know, Ned, do you feel the excitement? It seems that there's so much going on. Neuroscience. I mean, I see a lot of stuff on the internet, and a lot of it I don't understand, but I just see a lot happening.
You know, this is a good segue point. I don't know if you're about to do this, but here we are in the depths of the brain, literally. I'm just talking about electrodes going into the core of your brain. And it's amazing. I'm talking about laser surgeries of the emotional part of the brain. But boy, that's invasive. And that can only be done in this particular subset of patients. It's not really going to help someone out there who just wants a more expansive memory, or someone who wants to be able to recognize people better, or someone who's on the autistic spectrum and wants to recognize what people are saying and thinking, more particularly, and their emotions. So it's not going to help. We're not going to put probes inside their brains, so what can we do? And this time between my PhD and now, which is about 7 years, has been one of me understanding that we need to be able to do things that are less obtrusive, by far, and thus the wearables. And at the end of that story, we get to Google Glass. I could fast forward the story and say that even while I was doing my PhD, I was working on a project for the Army, and this was in wearable brain monitoring. But at that time, wearable meant 15 pounds or less.
Wow.
Huge apparatus, hairnet, big control pack, battery pack, etc., all custom. But that still was a whole lot better than being in a clinical setting with all the rigs, dozens or more electrodes on the head, and completely immobile. And by the way, in that kind of a facility, as opposed to in a forward area. So clearly that wasn't going to work for the Army. They needed something portable. But even at that time, there was no standardized portable device of this kind. So I realized, yeah, we need to get a lot of this information from scalp EEG, not from implantable EEG, and we need to get this information when a person is moving, sweating, covered in sand, as opposed to this perfectly spherical test subject in a vacuum in a lab somewhere. And so I was moving in that direction, but the tools weren't there.
Okay.
And without the 10 years in between, let's say, from that project to now, I'll just say that Glass gives us that kind of answer. We're getting further and further away from the technical rigor of the clinic or of a research study where we can study the fine details of a past tense verb in the brain signals when you're speaking. But we're getting towards practical, something that's usable by a regular consumer, that person who just wants a better memory, and out there in the field. And what I realized, even from that Army project back then, was we can't build everything from scratch, or there are 1,000 possibilities of failure, 1,000 parts of the system that might not work, and that if we get working are so custom that the operator has to be highly skilled, and if something goes wrong, the maintenance person has to be highly skilled. So I knew it then, but I didn't know what I was looking for. But when Google Glass came out, I realized this is a head-mounted computer. It has onboard sensors. This is the perfect centerpiece for a system that is actually wearable, that's being maintained by another company, and it's a company that has a lot of investment, let's say, in this project, and a sense of what consumer devices are like. So instead of building from scratch at the device level, we're using an existing device. We're using Google Glass. And then the custom work comes in the algorithms, the neuroscience basis, the understanding of the clinical presentation of these disorders or maladies. And so our value add is my training, the MDs on my team's training, and the Android coders on my team. I'm proud to say I do some of the coding too, but not starting from scratch on the device.
Let me ask you about the coding. I mean, developing for a regular old Android device, a phone, is pretty straightforward now. Most people could do it if they spend the time. How does that translate to Glass? Is it a whole new separate environment? I mean, do you use, like, say, Eclipse for something like that, or do you use a higher level programming environment?
So I use Android Studio and Eclipse, and Glass is not Android, Android is not Java, Java is not C++, C++ is not C, etc. And yet they are. I mean, they've inherited from each other. And Android is a really nice, feature-rich version of Java and Plus. And then the step from there to Glass is a smaller step. I mean, it is Android. It's a whole different form factor. So the most important difference is understanding you're designing for this tiny little screen that hovers here, as opposed to an immersive tablet or phone environment. But also there are factors to the GDK, the Glass Development Kit, that sits on top of Android that is for Glass. It's a whole different environment. It's a voice-activated or maybe tap-activated thing. As soon as you get into your main activity, you should have most of what you need right there. Menuing should be very slim, very simple. Information should be glanceable. Again, it keeps going back and forth between the UI and UX aspect of this and the actual coding. But the coding does require knowledge of the GDK. The GDK does change every month, and your code breaks, and you have to start again. Features get swapped out. But that's the nature of being in a beta program. It's kind of neat to see it, to see the brushstrokes. You can even see it if you kind of tear down the newest releases and see what commands, what voice-activated commands were in there, and you can see where they were trying to go. And sometimes they hit a dead end and pulled back. Sometimes they add more features, and then it's more publicly released later. So it's fun in a way, but it's definitely a moving target, and it definitely is different from regular Android.
So if you have an APK file for your phone and you want to migrate to Glass, and you have it optimized, like you mentioned, your activities and various threads and all, is that easy to do, or is that a complex process?
Well, you can't put the APK on there probably, because if it was made for a phone, it won't have a voice trigger, for instance, and so it just won't show up in the OK Glass menu, things like that. But if you have the code and can add a few lines, then it's probably pretty quick, but it might not work very well if it was optimized for a phone. That is to say, you would need to insert a few extra permissions. You'd need to be on the right API level and call the various libraries in the GDK. But you could do that pretty quickly if you had the code. The problem is if it's going to give the user a series of icons and you have to choose one, that's just untenable on the Glass screen. It's not the point.
Okay.
Ned, I have a question, and I'll show you this platform after we're done, Ned.
Sure.
We can get tweets from people that are watching, and I've got one tweet from Dave Martineau, who's a hand surgeon from Dayton, Ohio, who's going to speak at the conference about glass and hand surgery. But he asked about, do you have any input on the implants for depression and Parkinsonism? Do you have any experience with that kind of thing, or?
Yeah. Well, so my previous research especially crossed over a lot with DBS work. Basically, they're implants that are temporary, chronic but temporary for these surgeries that I mentioned, and then they're the really chronic implants, often with a stimulator implanted and part of it externalized. And so DBS, deep brain stimulation, is used for, of course, for Parkinsonian symptoms, because you can affect the motor system and basically turn off their Parkinson's. It's pretty amazing. Look up some YouTube videos on that. It's striking. And depression and other things where some parts of that the entirety of that psychiatric condition may be more and less well characterized, but when the clinicians, when the surgeons view it as possible to remediate in that manner and treat in that manner, I do know, I'm aware that DBS is used. I don't cross over in that. I don't deal with that clinically. I know that that's very important. And I would wonder, what we can do with glass. And
Yeah, I was going to ask that. I was going to ask that. You think that DBS glass will somehow make monitor it more closely, or actually improve the field of DBS?
well, absolutely. So some things have to move slowly because they're heavily regulated and go through FDA, and of course you can't just stick something in someone's brain and hope. So
Right.
the part that's inside would have to proceed very slowly in terms of its innovation cycle. And what I could see would be two ways, two directions. One, glass communicates with the DBS um, setup, which is to say the externalized sensors that glass can present could trigger the DBS, which is to say if there's a likelihood of a seizure, or the glass IMU, which is the gyroscope, accelerometer, and magnetometer, pick up body motions that signify some of these motor disturbances, Parkinsonian or otherwise, then they can signal the DBS and quell the symptoms. And also be an adjustment cycle if that's not working. Why is it not working? Has that glass has been able to maybe learn the motor behavior of that particular patient and customize the response for that one, and or resort to stereotyped motor plans or let's say stimulation plans to quell the motor behavior. So I'm just pontificating there, but I would imagine the two types of devices working in tandem: an externalized, replaceable device, and then the internal device.
Mm-hmm.
That as a system would still have to be FDA regulated, I would imagine.
Well, I would see a problem with that. I mean, a glass-like device actually replacing the Medtronic or the other manufacturer's custom interface. The problem would be reliability. I mean, just programming Android, say you're trying to maintain multiple Bluetooth connections or even Wi-Fi connections over 3G or whatever your connection, it just doesn't really work too good yet. It's not reliable.
The important word there was yet. I mean, I'm not saying we should throw this at a patient tomorrow, but at the same time, if we looked at the reliability of the first batch of phones or computers and said, let's stop, let's go home, there's no chance that a computing device will ever do anything useful like guide traffic or guide surgery or allow us to understand data from huge populations. Well, we know they can now. We know they couldn't then. So glass would not be useful tomorrow in this kind of a thing, but a much more ruggedized, stabilized device could. So I guess the question is not about glass. The question is about the crop of consumer-targeted wearables. Insofar as they can be made a little more stable and rugged, can they be used for medical purposes? And I think you and I and this group here would say yes, it just might not happen tomorrow.
Yeah, I mean, I think using them for simple things like hearing implants may be the way they would first gain a threshold. I mean, not cochlear implants, but just external devices that the user can just control volume or other functions with.
That's a really important one, and I hope a lot of people are working on that. I wanted to, but I have to stay focused. I was saying there's two possibilities. One is an implantable communicating with a wearable. The other would be stay in the wearable and try to do the same kinds of things that I'm saying I've matured toward, which is accept that you can't do as much medically or clinically, but you can affect many more people if you can do something that can live completely in a wearable device. So maybe they, let's say someone with vestibular issues, we can't necessarily stimulate internally, but we could give them guidance, give them feedback as to their current state of balance and motor regularities. You also mentioned DBS for psychiatric ailments. Maybe we can't zap and cure. Maybe it's not like giving a pill to cure, but there are controversies about whether that's the right approach. I've seen rumors and small amounts of information about gamified experiences that replicate some of the psychiatric interventions, things that are related to cognitive behavioral therapy, where the experience is largely like playing a video game, but it's a very specific type of video game that's capturing data at that time and is also instructing them in ways that can help one way or another with the condition.
Mm-hmm.
Ned, I know you're on vacation and you probably don't have I don't know how much time you're spending on the internet, but let me just show you real quick screen share this article today, which I'll give it to you after the talk.
Sure.
Out of Stanford, they're using deep brain stimulation to eavesdrop on problem neural circuits. They had this device that I'm showing you now is what they call a brain radio. That you got to watch this video after we're done because it shows a Parkinsonism patient when this brain radio is turned on as opposed to when it's turned off, and it is remarkable. And
that's what I said. I mean, YouTube these videos, it's striking. I mean, you have someone who just cannot stand, cannot maintain balance, and is really presenting with some very rhythmic and frank motions, and then you turn it on, boom, they might as well be dancing. It's extraordinary.
Yeah, it was marked. It's very, very noticeable.
Yeah, so for sure. Now, okay, so these are interesting questions. I guess, John, you'd said maybe I should talk a little bit about what Brainpower is up to.
Yes, please.
Cool. Well, as I mentioned, we're trying to take advantage of the wearable platform. We're trying to take advantage of the glass platform specifically. And I think there have been some wonderful voices added to this conversation recently amongst the people who will be at the Watch conference in terms of medical use. And it's medical use often to make the doctor a better doctor, to create efficiency, to have interplay with the electronic health records, to give scans right to the doctor's eye while he or she is performing the surgery. And that is extremely important. I want to add a slightly different voice to this conversation, which is to help the patient directly, where the device lives on the patient or in the family of the patient. And by the way, calling them a patient is funny because they're a patient for that one day that they come in to see the doctor, at which time the doctor doesn't see how they naturally behave because they're at a doctor's office. But every other day of their life, they're a person. And they're a person potentially with a condition or with a desire to enhance their natural capabilities. So it's patient-centric, or actually person-centric, uses of glass, but within the larger penumbra of healthcare or wellness promotion. And our focus is the autism spectrum disorders. I'll just say autism rather than that longer word. But so in terms of autism, there are 1.1 million children in America with a diagnosis of autism. There are 1 in 68 children now are being diagnosed. It's a huge set of human beings who have a lot of challenges as they develop in learning the language and social interaction and behavioral control that we take for granted. And there's a huge diagnosis gap. The average age of diagnosis is 6 years, and it could be 6 months, newer studies are showing. And in fact, some studies have shown that behavioral as well as neural effects begin so early. They're showing neural effects before birth, and they're showing behavioral effects often to do with eye contact and eye motions almost instantly upon birth. One of the things that children do universally is mirror. They mirror the motions and emotions of the mother or the caregiver. But that's very different in stereotypical children with autism. And those can be real telltale signs. However, parents might not know what to look for. and may not know whether something they're noticing is going to resolve itself, and when to seek care, and how to get that care, and by the way, it might take a year to get an appointment, and so forth. There are many reasons why there's a diagnosis gap, and then once given a diagnosis, now what? Perhaps some services will be available from the school according to federal mandate. That's if that school is being so cooperative, and then what? There's an information gap, and on what to do. So we're trying to address, on the one hand, assessment, trying to give quantitative data to parents, to families, on the features of autism. Not autism as a whole, because it's such a wide gamut of features and of phenotypes. And assess the progression through time. Let's say the parent has the money and can send them to a special autism school. Are they getting better? What does better mean? How do you quantify this? And then assistive tools. So here is a person, a young person, and an adult person with autism of one flavor or another. How do they reach goals that they may have? So one thing that's interesting is a person on the spectrum might have wonderful talents, might have raw brain power that could allow that person to be a very good econometrist, could be a very good coder, but may never pass an interview to get into a company because their ability to make eye contact, recognize social gestures, and control some motor behaviors may be outside of what's called normal. If we can give assistive tools for those three features that one does as if doing piano lessons for 2 hours a day, training, might we not be able to help those people? I'll get more specific pretty soon, but so this is our goal is both assessment and intervention or coaching, training, and with in between being tracking, and that tracking for progression of hopefully improvement can be used in a family to understand the child, can be used by an educator, can be used by a clinic, and can be used for clinical trials insofar as new drugs are being used or new interventions. How do you know how well the children are doing? Right now there's not that much that's standardized and quantitative. So those are some of the goals and problems, and I suppose I should get to the solutions. But do you have a question?
Yes, exactly. How does glass fit in as far as assessment? Because I guess there's no lab test that will diagnose autism. It's kind of a subjective diagnosis, correct?
There's no blood test for autism, although I do have a friend and colleague who's working on it. And there's no genetic test. Unfortunately, the genetic picture is getting more and more complicated. There are more and more genes that may be involved. Hopefully we'll find clarity, but right now there's no simple test. Diagnosis is clinical. It's based on observing children playing with their caregivers, interacting with certain standardized tests and play settings, and then certain lower level psychometric features. This can be, as you say, subjective because the interoperator reliability comes into question. Different clinicians having different amounts of time, first of all, with the child, and different internal sense of what categorizes as one of the clinically relevant behaviors. On top of that, we're talking about children who like routine, and they hate things that are outside of their routine or foreign or too bright or too loud, and you're taking someone from a home and bringing them into a doctor's office and putting them under pressure. They're probably not going to behave in the same manner as at home. Glass lives in the home. It's a first-person point of view camera living on the parent or on the child. And they have to get used to glass, but so far it seems very, very favorable that they will overall. Some may not, but overall they will. And once that hurdle is passed, then that assessment proceeds in a normal, ecologically normal environment. So let's say the caregiver calls child's name, and child orients the caregiver. Or caregiver calls child's name, child doesn't look. Calls the name again, calls the name 7 times, there's an exasperated tone in the voice, and the child is not looking. Well, this is a possible indication of something being wrong. In and on its own, maybe that's not enough. But now add to it certain stereotypical motor behaviors like rocking, add to it certain fixatedness with some of the materials that might be right in front of them. We start getting, okay, more of a picture here. This is towards the assessment. Well, what is glass? Glass has this gyroscope in it, an accelerometer. Glass has the camera and a luminance detector. Glass has a microphone. So glass can determine if they looked at mother. Glass can determine the rocking motions. Glass can determine, for instance, if there's a change in luminance, if there's a sudden light, does the child let out an utterance? Does the child stim, which is a type of behavior that is often looked at as something that a child will do to control their environment by, one thought is overpowering the other stimulus that's coming in. So these are quantitative, quantifiable events that we're measuring. And we already have prototype software of many of these things. The 3 core features we're looking at, as I mentioned, is social interactions, language, and motor behaviors. In social interactions, we're looking at eye contact or head contact, let's say, orienting towards caregiver, decoding or recognizing emotions in the face, and recognizing of socially relevant events like the name being called or a phrase like "I love you," and on the one hand, assessing, quantifying them, and on the other hand, intervention, prompts, an indicator that, for instance, the facial gesture is a smile, and a prompt as to what to do, smile back. And it's going well so far. The software, I wish I could demo for you, but I will maybe in a demo reel I can just pass on.
Okay.
One thing that comes to mind to me, I mean, if you're going to ask or require an autistic person, or for that matter, a normal person on an interview, to maintain eye contact, you can't just say, okay, make eye contact. The question is when to stop eye contact.
Well, for sure.
I mean, you also you need a theory behind of, almost a courtesy or, to consider. I would call it the cognitive load of maintaining eye contact. I mean, it's probably hard for these children. I'm not an expert, but to maintain eye contact because it limits the excursions of mind that they would normally do. So
Yeah, absolutely. Remember, we're not trying to yet dial in really fine-tuned and get into the every nuanced behavior of when you should make how much eye contact and what that says about social hierarchy and so forth. We're talking about a child who will not look at the parent potentially at all. And the parent feels that it's just not getting back any of the emotion, the love, the care I'm putting here. And we're talking about, at first, not even eye contact, just orienting the head in the general direction. And we can do that by establishing the allocentric location of the person, of the parent, and one of the apps we have creates an arrow. So when the moment is right, and you're right, we have to determine when that moment is, but for instance, when the name is called, then the arrow shows up indicating the direction to look and how far away it is. As I look towards it, the arrow is smaller until it's a point. As I look away, the direction changes with my head orientation and the arrow grows. Very rudimentary thing now, but what's good about it is it's glanceable. It doesn't show up until it's needed, and it's very small, and it's a guide that's interactive. As they move, it moves. So that's just one example of a very rough and simple type of guidance point, but it's toward at least what we can say is relatively universally the right thing to do at that moment. That's different from the detailed eye contact, how long, when to disengage. At first blush, it's just encouraging the very basic behavior, but also importantly, measuring when it does and doesn't happen. Again, very, very gross motions like looking at all, uttering sound at all. And also saying we focus on language. One problem with language is it's often taught socially. Hey, Johnny, look at this. Okay, I'm looking at it. Yeah, Johnny, that's a cup. You put water in it. Now Johnny's looking somewhere else. And parent still talks about the thing that was originally intended to. The child's job now has to be both learning language and guessing what this other person is thinking about and why, and what are the nuances of that interaction the other person is asking the child to have with the environment. Glass lives on the head. There's no reason to have to compute another mind in order to learn the basic elements of the surrounds. Instead, we put QR codes on everything they see, and as they see it, the QR codes inflate into the word or a visual icon of that word, and it's spoken directly into their ear, and if they speak it back, they're coached as to their pronunciation.
Okay. How evolved is that project with the QR codes, and how fast does it work?
Yeah, well, we're not sure exactly why it sometimes slows down. I think we've been trying to put it on the GPU, and we don't really have access in the GDK to force that right now, or at least I'm not sure that we do. So it might be sliding back and forth, and sometimes using the GPU, but right now there's some intermittent slowing, but it's pretty good. I mean, I'm talking about something that's looking at every frame of a video feed. So it's however many frames per second, and in each one it's looking at every possible box in that frame and looking for a QR code, computing it, and simultaneously inflating it and writing it into the next frame of the video feed. So it's not like you look at one QR, get the answer, and you're done. This is real time, and it's in the environment as they move around.
Do you use a platform like OpenCV to pick out features, eyes, stuff like that?
Yeah, we've used a lot of different libraries, certainly OpenCV, the inventor of which is a friend of a friend, so I'm kind of excited to meet him. I haven't yet. And we use other libraries as well, and it's the integration has been quite good with Android and with Glass.
So, Ned, you've been mostly concentrating on autism.
Yeah.
Do you see promise in other developmental neurological abnormalities? Or have you heard people say, maybe we can use it for this type of neurological developmental abnormality?
Yes, yeah, absolutely. And I wish I could get distracted. I'm a distractible person.
No.
But
No, we appreciate the work you're doing with autism, but I'm just asking generally, do you see, other people saying, wow, we could use it for this developmental thing, and etc.?
Absolutely. And ADHD is one that comes to mind immediately and is comorbid, of course, with autism very often. And so many. A couple of the things that we have as missions here or as philosophies as to why we're doing this. First of all, why autism? In autism, we feel we can make a really large impact on a really large set of people who have major challenges in their way. But if they were to get through those challenges, have every reason to achieve independence and be able to contribute broadly to society. On top of that, the neural work is actually not as hard. We wanted to look at, I was naturally thinking of epilepsy. I've been working with epilepsy patients for so long. But the neural work, the predictive algorithms to predict a seizure, is actually shown itself to be pretty difficult. And we need to be collecting the EEG and so forth. With autism, we will eventually collect EEG. We will eventually collect all kinds of physiological signs, GSR, SCR, electrodermal response, and so forth. But we don't need to right now, because just the behavioral and quantified behavioral stuff is enough to actually make an impact.
Would you say that it's a delay in the diagnosis of autism that's a big problem, or is it the inadequacy of treatment, or both?
Oh, for sure both. For sure both. But delayed diagnosis, if we take seriously that the average age is 6 years, there are 1.1 million currently diagnosed, and it could have been 0 years, then that's 6.6 million human years of life that have not been addressed, where the education was not done in the correct way, apparently because the diagnosis wasn't delivered. Now, those numbers, maybe that's a funny computation, but think about that, the profundity of 6.6 million years of human life. Important years, the formative years, the language learning years, the social structure learning years, not being correctly addressed by the system.
Mm-hmm.
If you have a tremor and your stimulator's on 100% of the time, it doesn't sound like that's ideal. I mean, you'll adapt to it. If you have a sensor on your arm or a Myo armband or something that picks up the tremor, could that activate the DBS stimulation? I mean, would that be a feasible thing to do at this point in time?
Yeah, so I can say categorically and theoretically, this is kind of what I was saying before, that the wearable can trigger the implantable. So you have the DBS, if there's an accelerometer on the wrist or arm with the Myo, or it's on the head, who knows, to some degree who cares, both depends on where the tremor would be. But if that can trigger it, sure, that seems logical. I'm not directly in that field. I can't say as a clinician, yes, we could do that. It makes a lot of sense.
Ned, we have Paul Sotek, the head of the conference, on here. Paul, say hi to Ned.
Can you guys hear me? Can you hear me?
Can you hear Paul? Can you hear us?
I can make out the words, but they're a bit muddled.
Oh, yeah, I'm on cellular. I just wanted to come on and say, you know, it's a real honor to have you as part of the program, both for the conference and for the, you know, to be here in the pre-conference hangout. It's a pleasure to meet you. And thanks for really, you know, doing this and giving us your insight and everything. I do appreciate it. I apologize. I'm in the middle of going to my son's 6th birthday, so it's kind of bad timing for me. But, you know, the only question I would have, Ned, and you may have talked about this or answered, was potentially, how are the autistic kids reacting to wearing the glass?
Yeah, so everyone wants to know this, and a couple categorical responses. One, remember, we who are on this conference call are all young at heart, of course, but we're kind of dinosaurs. Kids naturally get technology now. They like it. They really get it.
Okay.
And at the same time, I have to hedge and say, we can't help everyone, sadly, at least not in this iteration. When glass is something that you can't even see, it's a little dot on your nasion, and it's semi-embedded, then everything will be easier. But even as semi-cumbersome as it is, and I would contend it's a fairly slick device for as powerful a computer as it is,
right.
But as semi-cumbersome as it is, children at 18 months have been fine with it and kind of excited, kind of annoyed after they get it. They're looking for the next features, like tapping, swiping, doing these things. So they kind of get it fast.
Sure. We've seen sort of the same thing with the iPad. You know, they seem to get the iPad real quickly. And, you know, my own, and I'm by no means, I mean, just from medical school and kind of dealing with some of the Asperger's, autism, that spectrum kind of thing. I know some of them have kind of things with their heads and their faces, and that's kind of what I was asking, you know, I mean, are they tolerating it well, I guess, from that, you know what I mean, standpoint?
Yeah, so I would say that some just won't, but some,
okay.
That will be part of the training, the getting used to.
Sure.
They like predictability. They don't like extra stimuli that surprise them, but can get used to it. Can get used to wearing a hat or clothing that might scratch. It may not be perfectly fun. Hopefully, there's an attenuation curve. I think that's one of the issues. Is the sensory attenuation curve is just not as pronounced in children on the spectrum, but hopefully many of them will be able to get over if that's their initial response. So far, we're quite hopeful about it. So you mentioned the iPad. There is an issue with the iPad. If you give an iPad to a child, whether on the spectrum or not, you might have really given something fun to that child, but you might have lost your child. You might never get them back because they're so engrossing. There's so many cool things for them, but it's here. And now they're facing into that world of the iPad. And I'm not saying this as an old curmudgeon, oh no, technology, but it's the form factor. Glass lives on your face, and you see the world through it. So if they're looking out at the world, if they're looking for faces, that's still a better step than staring at an iPad. If, for instance, we give them a game that every time they see a face, it turns into John Malkovich, which I actually have coded, and I can send you the APK, that's fun, especially for us who saw the movie. I also have a mode where it turns the face into an angry bird, or hovers an angry bird next to them, so they can still see the face. So that's presumably fun, and they now have to go out there in the real world, find a real human being, and stare at them in the face. So step one, get out there. Step two, make eye contact. Now, to your point earlier, step three might be a little funny because you also have to tell them to stop staring at the face, but we'll get there.
Wonderful. Hey, like I said, thank you so much for agreeing to be a part of the conference. We're really excited to have you and doing this. I'll try and pick up a little bit later. I got to bail. I got to help carry things in for the birthday party. But thanks again, John, and it's nice meeting both of you guys.
Paul, you don't have your special glasses with you?
I don't have the glasses with me at the birthday party today.
You got to see these then. They're great.
We'll break them out next time.
Okay, Paul.
All right, take care, guys.
Okay, Ned, one thing, a quick question. What would you change? We had a great meeting yesterday with Cecilia. I think you know her. And a couple of neurosurgeons and another designer from LA. I think this platform is a great way for people like you, scientists like you, to get together with app writers and designers to say, can you possibly change the form of the Google Glass, or could you possibly do this application? Do you feel the same way sometimes about you and your studies? Do you feel that there's some change in the actual design of the glass that you would do, or the type of applications you would need to help further your study of autism?
Absolutely. First of all, I want to say I'm impressed with glass as it is, and it is amazing. I also know that hardware cycles are long, and their patents, if you look at them, design patents and utility patents, are several years old, meaning the glass that we know had to be solidified in their production cycle quite a long time ago, and now we have to deal with glass as it is. And they upgraded from ice cream sandwich to the newest, and now we're probably going to get to L at some point. And the hardware might not be keeping up with the software, but they did a lot to get us a really wonderful device as is. That being said, there are some limitations, and in our work in autism and in our work, actually, I didn't even mention yet, in traumatic brain injury, we've come up against those limitations at the hardware level. I'll separately talk about software. So, of course, I think you can resonate with this, that there's a battery life issue. And it's gotten more pronounced with the version 16, 17, and 18 of the software, as well as just the being on the newest version of Android. So that's an issue if you want to be in the surgical suite or in the home. Google's mission is to get technology out of the way, and they do that. But technology suddenly takes the center stage when the device shuts off. If you're in the middle of your child's wedding or first steps or birth and you're recording and it shuts off, technology is suddenly in the way. So in order to get where we needed to get in autism and in traumatic brain injury, we had to engineer around that issue and related issues that are for data and data security. So I went to MIT. I had my own engineering predilection, but I got some real hardcore engineers from MIT, and we've engineered something. And we now have an accessory pack that ruggedizes Google Glass and makes it more appropriate for the hospital environment and for the military environment. And that's something that we have prototypes of, that we're testing. But the production cycle, as I mentioned, takes time and takes effort and some resources as well. So we're actually planning to Kickstarter that pretty soon. We can just tease with that, and I'll get back to you with more details there. But we realize that it's not just our problem. It's not just for autism, but any user of glass, especially a trade and enterprise user of glass, will run into the same hardware issues. And so we thought the community might want this too, and might also be able to give us feedback on which additional features they want, because we have a few cool ones that we've mocked up.
Yeah, well, hopefully we can work from the ground. You can work with the designers from the get-go and communicate your wants and needs. And I tell you, Google Hangouts are a great way to do that. To kind of put your thoughts out, to say, well, can you change this? Can you change that? But are you saying that you're kind of constrained by the patent of Google? You really can't monkey with the actual design of it?
No, I'm not saying that. The patent discussion was to say what pressure they're under. That they had, it's been a long time, and the device is what it was, and not what it will be, and it still is. But now, so there's the hardware that we're addressing. Now, you make the point about telling Google what we want, and I found them to be extremely receptive. That's a developer relations team, Timothy Jordan, and his team, and up and down the chain, I have met with Timothy many times and explained some of the things that we would love to see, and he takes the feedback, and Jenny Murphy the feedback, and they really are receptive. At I/O, I had the opportunity to meet with Ivy Ross, and she's the new director of the whole GLASS program, and I met with her privately for an hour, which was really cool, and she said just what you're saying. Tell us what you want. Tell us what is needed, and no guarantees, but we're taking this feedback and we're going to make it better, not in general or in theory, but for the people and companies and entities that are using it and using it for purposes that are good and that need some additional hardware and software. I can't say she didn't make me any guarantees. I'm not communicating any guarantees here, but I'm saying that their philosophy is extremely receptive.
Well, Ned, you said that was golden, what you just said, because, when I got involved with this conference with Google Glass, I was under the impression it was a pretty well a niche device for surgery and for various other things. But the more I get involved with it, especially programs like Augmedics based in San Francisco, Dr. Chrono's putting it into their EHRs now for normal doctor-patient visit. I'm seeing it as more of a mainstream thing, and I think that the industry of medicine is going to have a huge demand in every special niche. In other words, the cardiovascular surgeon or the interventional cardiologist who we had on the other day, Jordan Saperstein, his needs and wants as far as design and application wants are going to be different from someone like you or a regular, a doctor, everyday general practitioner. So certainly that connection, Timothy Jordan and who was the other person you mentioned?
Well, Jenny Murphy, especially in terms of the GDK and software, but also Ivy Ross, the head of GLASS, sits over the whole program and the whole mission and budget. Yeah.
Well, there's going to be a lot of medical people wanting to talk to them because every part of I think this is going to impact every part of medicine, and it's going to grow. Now, the banking industry, I think, is going to have so many wants and needs, but they're limited. But medicine is so huge, as you know. There's so many areas to it, and this is seems like such a useful device. Some areas will be more useful than others, but it's going to grow. It's going to grow. It's going to morph.
It is the future, and it's now, and it will be more and more useful. But now, one thing to do is step back a little bit and think, what is glass? I mean, glass right now is an all-in-one device that lives here, where several parts of it are useful because they're placed there, but some parts are not. And it tethers to a phone, and the phone is this giant collection of functions all in one place. They're in one place largely because we're a slave to a single connection to the rest of the world. We have one data plan from our phone data provider and one device that we want to carry. But I would contend that we would not want them all in one place if we didn't have to, if they could independently communicate with the network and with each other, and where their particular function would be best placed. So I see a future, 5 years, 10 years, where wearables are an ecosystem on the body, and they melt as much as possible into the body. So it's not one visor that does everything, but the camera lives near the eye, the motion sensors live on different parts of the body that are relevant, physiological sensors live near the organ that they're sensing, and general horsepower can live in a pack as well as battery power, somewhere on the body that's the least intrusive of all, and can be placed functionally and dynamically as you want. So I don't think it needs to be all in one place. The head is extremely useful for some functions, like the first-person point-of-view camera and some of the sensors that can get head-related data, especially from the eyes and from the brain, ultimately. But many other things don't need to be placed so obtrusively. So I see a whole collection of devices forming an ecosystem in the future.
Yeah, I think the future is going to be pretty exciting. And Ned, I don't want to keep you too long. I know you're on vacation in Turkey, and I'm sure there's lots of things to do other than talk to us. But we really appreciate you coming out and taking time from your vacation. And hopefully
I really appreciate it. Next time I'll get a chance maybe to talk about the traumatic brain injury work we're doing also with glass. But I really look forward to the conference. Sad I can't be there in person, but we would be remiss, given what we do, in not having virtual and remote attendees. So I'm just happy to fill that role.
Yeah, please do. And John, thanks for taking part.
Sure. Yeah.
Okay. Ned, you have a good vacation, and hold on. I'm going to shut the broadcast off. We'll talk a second. Okay.
Okay. Thanks.